Students, let us look at one example where the second derivative test is inconclusive to determine the nature of the stationary point. So we are given y equals to 5, x equals 6 plus 1 to find the x coordinate of the stationary point. So we shall look for dy dx. So y is 5x equals 6 plus 1. So dy dx give us 30x to the power of 5. So therefore, at stationary point, our stationary point, dy dx is 0. So we know 30x power 5 equals to 0 and x equals to 0. So this is part 1. Alright, the x coordinate of the stationary point is 0. So now, if we are going to use our second derivative test, so therefore d2y dx squared. So differentiate this, so give us 150x to the power of 4. So when x equals to 0, our d2y dx squared is actually equals to 0. So this is where the problem comes in play. When d2y dx squared, when it's negative, when it's less than 0, we know that it is a maximum point. When d2y dx squared is positive, more than 0, it gives us a minimum point. But now we have equals to 0. So therefore, it's not positive or negative, it is inconclusive. When such thing happen, when it's inconclusive, meaning we cannot use our second derivative test. We have to fall back to our first derivative test. So we have to go back to the first derivative test. Sine of dy dx, sketch of dy dx in our table. So we create a table. The value of x is 0. So when the value of x is 0, the sine is 0 as well. Okay, it's 0 as well. So the sketch is a horizontal line. No, a value slightly less than 0 and a value slightly more than 0. To use a value slightly less than 0, I will use negative 0.9. So the dy dx in this case, so our dy dx is actually 30. Let's use a value slightly less than 0, so therefore negative 0.1. So negative 0.1 is to the power of 5. This will give us a negative value. It's a negative value here. A value slightly more than 0, we can use 0.1. So dy dx 30, 0.1 of 5. This will give us a positive value. So therefore, it's negative. So this is the shape. It's positive. So this is the shape. So in this case, falling back to the first derivative test, so students, in conclusion, when the second derivative test, when it is inconclusive, meaning our d2y dx squared equals to 0, it's not positive and it's not negative, we have to fall back to our first derivative test to determine the nature of the stationary point.